things that I like about OBS. There's certain things I like about Screencast. I also liked that OBS was free, but I have paid for Screencast now, so I have it for 3 years. So, all right. So today we are getting into surface area of pyramids. I doubt we'll really do much with volume, just because we won't have time today. But I left you guys last week with a challenge, and I pretty much said that I didn't think anybody was going to step up to my challenge. Because, I mean, I don't. How many more people need 13.3?
I need...
Because for some reason we're way short on copies for 13.3. Like, a lot of people had to take extras or something. Or people moved them over here and now they're in the wrong place. I can print more if we need, but... Anybody else doesn't have 13.3? Print a couple. Anybody else? 13.3. You don't have it. Hands up right now. If you do not have 13.3 in front of you at this moment. Okay. Back at 13.1, we...
Good afternoon. Please pardon the interruption. Thomas Gibby, please come to the office. Thomas Gibby to the office, please. Thank you.
No. We did 13.2 yesterday. If people have questions, I'll take them, but you don't need it out. Yes, there. Yeah, you can't see it now because I don't want to write on it, but in the video it has picture-in-picture.
I think you should. Personally, I think you should figure something out about that because sometimes you write and slow down there.
Yeah, if you're working along with us, like that shouldn't be a big issue. There are settings here where I can leave it there, but I don't do that intentionally because then you get an infinite tunnel where a video films itself filming a video, and it doesn't really make any sense. And I just try generally to avoid this space, which is about as big as it is. So I appreciate your feedback, but some thought went into why I do that.
Well, I think you should...
Can we talk later? Because we got to get into class. I'd love to hear more about your opinions, but I don't have time for it right now. Does that make sense, dude? Can you catch me not during math class? I got to teach. We're running out of time. So, I would hole punch those. If you're one of the people grabbing those, I would hole punch it right there. Yes, sir.
Where did you get that shirt? I don't like it.
Off the internet. One of my friends, because I'm a nerd, they bought it for me for Christmas.
Really?
So,
Are you serious?
did anybody step up to the challenge and earn yourself a pizza party and solve these problems?
Wait, you're telling us this now?
No, I told you this at the end of class.
Yesterday?
I said step up to this challenge and there will be a prize reward, whatever, for anybody who rises to the challenge to try to solve these two problems.
I can do that now.
Doesn't count now. That's like saying the deadline was yesterday. Oh, let me do it now. You should have gone home or gone from class last week. You had all extended weekend to do it. You got work written down? You didn't want them? Let's see if it's right. So, Ellie did one of them.
I don't think it is, but okay.
What do we do with a hexagon before we can break it up?
You divide it into 6 parts.
We divide it in. Now, what are those parts? Why are we dividing it into parts?
Because it's easier that way, and I can just multiply all the little triangles.
Ah, because it's easier to split it up into triangles. Your hole's not moved up. It's easier to split it into triangles. If you want the original one, you can have it. You just seemed upset that your hole went off the page. It's up to you. You can choose either. Triangles are a lot easier to work with. So up here on your paper, you should have the general area formula for any polygon. It's the number of edges times the triangle formula. So, hexagon, 6 edges. Everybody on your paper, draw lines to break this up into triangles. We are now going to start by calculating the big B, or the area of the base. What's up? Yeah, always. I got them there, yardsticks back there, whatever you need. So if you need a meter stick, yardstick, check which one you grab. Some are just metric, some are just American. We are now you guys can write down here, but I'm going to run out of space because I write a lot bigger. So I'm going to start calculating big B here. We're going to do 6 times our triangle area formula. How does a triangle, or how is a triangle different than just doing a rectangle? Ellie? Yeah, we use half times little b times little h. Little b being base of the triangle, little h being height of the triangle. How do we know the little b and the little h? They have a certain relationship with each other. Go ahead. What's that mean? Well, the little box doesn't mean it's the height. The little box tells you something else, but because of what that tells you, then we know it's the height. Do you remember what those two lines are called when they meet at that angle? They're perpendicular. So this right here shows us that these are perpendicular and will be my little b and my little h. So please write down this work. We're going to have 6 times 1/2 times, well, this edge will then be my little b, which we know over here, we're told, is 3, times the little h, we're told right here, is 2.6. Any questions on how I knew my little b and
Good
little
afternoon.
h?
Colin Williams, please come to the office. Colin Williams to the office, please. Thank you.
So then we want to compute. I can do half of 6 really easy. Order of multiplication does not matter. It's commutative. We can change order. So half of 6 is 3, times 3 is 9. Really, I'm doing 9 times 2.6, which comes out to tell me that my base area, anyone compute this yet? Olivia, you got it? 23.6. And that would be inches squared. Is that what you had? Or did you have something different?
I multiplied I didn't multiply the 6 yet. I did,
Area of one triangle?
What?
You did area of one triangle, then you did times 6?
I did yeah.
Let's see if we get back to the right place. Because you might have just taken a different road. So then, we need to talk about the area that goes around the shape. Because if we have a hexagonal prism, we know that the area of my base shape will be the same as my other base, because I have cloned bases connected by rectangles. So we'll end up doubling this, but here in a little bit. So I've dealt with both hexagons. We broke up the hexagon into triangles to deal with it first, calculated one triangle and multiplied it by 6. We did all that. Now we ignore those, and we really have one giant what left over?
Rectangle.
Big old rectangle. How you find the area of a rectangle is just its length times its height. Be careful. We've already used a height. So now when we go down to talk about our lateral area, which is the area that goes around it, we're going to use little p times big H. Little p represents what here? You can look back up your notes if you need. What will be the length of the rectangle? Where does that come from in relation to the hexagon? If the hexagon has these 6 edges and those edges all connect to those rectangles, that P is the perimeter of the base. If you don't remember that, it's on the front of your paper. Those formulas are on the front of your paper. So that perimeter of the base, we then will multiply by the height between the bases. That's our big H. So to get our perimeter, I'm going to work vertically here so we can see this. Each edge is 3. How many edges do I have? Around 6, right? So I just do 3 times 6 to get that perimeter. The height between the bases, we know is 4, the distance between them. You with me writing this down? No, you're not. Are you looking at the right notes? Because we're on the back of 13.1. So don't straight face lie to me. If I ask you, if you're with me writing this down and you're not even looking at the right page of notes, tell me. I'm here to help you. If you need the notes, I'll get you another copy. But you're not with me. You're not even trying to be in the right place. Guys, especially as we get into the final few chapters of the year, this is not passive. You cannot just sit here and think that I can dump info in, like, open your mouth, dump it in, this is how you learn. No. You have to do it. You have to write out the work. There's none of this sit here and wait for other people to solve it. Because I can see right now who has written this down and who hasn't. Because I know that I can write things down faster than you can, and when I look up and people aren't writing, I know you didn't write. And it's getting extremely frustrating. So, we should all be writing this down. That this 3 times 6 tells me the perimeter is actually 18 times that height between them of 4. Yeah.
That's
72. 72. And that again would be inches squared. Now that we know is our lateral area. To talk about every single piece of this. Well, our lateral area was this big rectangle. So we've got that whole chunk. If I could make it disappear, I would. What we have left, this hexagon, I already found one of them. So I need to double it and just do times 2. Very good. So to finish this out and find our total surface area, we're going to say surface area is the lateral area plus 2 times the big B. Here we computed, we're not doing this problem. Make sure you realize we're not doing this problem. We computed our lateral area to be 72. We need to double our base area of 23.6. And yeah, this will be under that little screen that blocks things. So I'll make sure to say it out. When we double this and then add it to 72, you got our final answer?
Yeah. I'm pretty sure it's wrong, but I'm just going to say it anyway. 3,369.
You may have done a multiplication where we wanted to do an addition.
That's what I'm thinking.
So when we double our 23.6, we get 47.2 plus 72 gives me 119.2 inches squared.
I multiplied them, I didn't add them. That's what I did.
I think we have a slight error. I think this is supposed to be 23.4. Because when I check that math, 3, 2.6, 0.5. So this should actually be a 0.4, which when we double it would turn into a 0.8. So this is actually incorrect. Sorry guys, it's 118.8 inches squared. This value right up here, we were slightly off on the big B, so I think whoever gave that to me just mistyped something. So I need you guys to try the got it on your own. I'm going to leave this process up here, and then after I take a couple laps, answer any questions, I'm going to start slowly writing the process up here. But you guys can talk with each other, ask your peers questions. If you need, stick me up a hand if you need me to help you. Do you have any what?
I was asking in case you're an eraser.
I got a block eraser you can use just for class as long as you get it back one. It's a really nice art one, so make sure I get it back.
Never mind.
I'm going to remind us what our process is. So you guys should be starting this on your own. You don't need to be watching me, but things we need to do. All right. So a little bit of teamwork here. Shuffle up. See if we can make it through this. Giving you a few more seconds to wrap up what you're doing. All right. Grady, what would be your first step here?
Finding a big B.
Sure, we want to find Big B. It's an important part of the process. How do I start to do that?
Is it 6 times a half times the perimeter?
So we're going to do 6
Base times height.
times, yeah, 1/2, little b, little h. Lateral area uses perimeter.
Yeah.
So be careful. If we need to jot that down somewhere so I remember each different formula, I could somewhere jot down that lateral area is going to use perimeter times really our big H, so we can differentiate between the two of them. So big B over here, to do that, I have to have broken up my hexagon. Sorry, my lines were a little off. My smartboard's slightly weird. Look for the right angle, the perpendicular intersection. So we see that right angle right here. That tells me this is my base, this is my height of my triangle. Little b, little h are perpendicular to each other. So I fill in, except I like blue, 6 times half. Well, I see 2 and 1.7. That's what I'm going to be using. This is pretty easy. What's half of 2? 1. What's 1 times 1.7?
1.7.
So I just have to do 1.7 times 6. This tells me each triangle area is 1.7. I have 6 of them. So when I multiply that, 6 times 1.7, 6 times 1 is 6. 6 times 7 is 42. Bring that decimal back in. And we get 10.2 in total. You can do it differently. I just did the multiplication in my head, doing 6 times 1 and 0.7. So I distributed 6 times the 1 and 6 times the 0.7. That's the thought process that I went through in my head. So we got our big B. Wonderful. Ryan, if I want to start looking at my lateral area, I know the 2 pieces that we need, the little p and the big H. What's that little p represent? Perimeter of... So perimeter and area are 2 different things. Area is space. Perimeter is distance around. But when we talk about perimeter up here, we did perimeter of this. Right? Like how far around the hexagon, because that's what my shape was named. Again, we have a hexagonal prism. So when I talk about perimeter, I need perimeter of the whatever the name is. That's what I'm taking the perimeter of. So please underline or highlight the fact that hexagonal is in the name. That's what tells me what to do. I need the perimeter of the hexagon. So to find that perimeter, what's regular mean, by the way? This word regular that keeps showing up in front of all my shapes? Say it louder.
All the sides are the same.
All the sides are the same. So this edge is going to be the same as this edge, is going to be the same as that edge, is the same as that edge, is the same as that edge, is the same as the edge that I actually know. What's the size of my edges? Ah, that's my height of my triangle. 2 is the edge length. So when we start looking at finding that perimeter, my perimeter is going to be 2 times the 6 edges that I have. Times, now this big H. Aiden, what's that big H represent? Height of height of the whole thing, right? Of the actual prism. So that height is height of the prism. What number up here shows me height of the prism? Yeah, because, guys, height doesn't mean tall. Height means how far from base to base. So, all because this 8 is not standing up doesn't matter. This 8 is our big H. It's the height of the prism. It's the distance between the bases. So we use that big 8. We get 12 times 8 gives me 96. I have 2 working numbers that I found as I went through my process. I found my big B was 10.2. Found my lateral area was 96. Piper, what am I going to do with my lateral area and my big B to put everything together and find my total? Add it, but we got to do something before I can add them, actually. You know, we're going to pass. Olivia? We have 2 bases. So remember, our surface area formula is the lateral area and 2 of the big B. Because we've got a hexagon on this end and a hexagon on this end. So we get 96 plus 2 times 10.2. When I compute that out, my final surface area comes out to be, Ellie? Thank you for the label. And I like to put extra labels on. There is no... So, in math, we don't love redundancy, but we don't mind it. So, like, we try to be efficient, but all because I had SA over on the left side doesn't mean that I shouldn't write SA again so that I'm aware, oh, that's my total surface area. Yeah. Tonight, midnight, but I mean, get it done when you can. I'm going to post chapter 12 stuff here really soon, but I won't post chapter 13 until we get real close to mastery, or normally day of mastery, like post grades for it. So just get it done when you can. Are there any questions remaining from 13.1, our surface area of prisms? Yeah, my board is having issues. Yeah, it wasn't it. Didn't work. Any questions from 13.2 that you guys did yesterday? Well, the video was fairly comprehensive. So volume, who thought volume was easier than surface area? There's less of a process, less things to do. Yeah, if you didn't, you maybe haven't practiced it very much yet, but volume tends to be easier. Most feedback that I get, volume is easier. So let's look at 13.3. If we had a prism here, let's just go ahead and imagine that instead of having a square-based pyramid like they showed me, they've got a square-based pyramid kind of broken apart here. Let's imagine that we had square-based prism. So one of the things that makes a prism is it's connected bottom to top by rectangles as opposed to being connected bottom to top by triangles. So they show me the bottom and the triangles. Blown up, we've got the net here. If it was a prism, so somewhere off to the side, right, if prism or something like that, this is why I use colors. So if prism, these would all be rectangles. And if it was a prism, then what could we say to relate the lateral area from the prism to what we now see as the potential lateral area to the pyramid? How can we relate the area of the side faces? Right, if we had a prism, I got 4 side faces that are rectangles, right? So we kind of drew those out here. We can see they look to be 3 by 3, so it looks like they'd actually be squares. My bottom here is 3 by 3, so if you imagine these are 3, everything's 3s. I got square faces around the sides. Square on the bottom, square on the top. We are not showing the square on the top, but we're looking at lateral area. So what we want to say is in a pyramid, I'm going to orient this really quick again. Again, I write faster than you guys. So go ahead off to the right there. Start writing in a pyramid. The lateral area, and you can abbreviate LA if you want. How does this space inside this triangle compare to what space would be in the rectangle?
Isn't it half?
It's half. So if we look at how much is covered by the triangle, like how many boxes, compared to how many boxes are covered by the rectangle, the triangle, well, sorry, so the rectangle would have 9, right? It's 3 by 3. Wow, that's off. The triangle only covers up half as much. Each of those would only have 4.5 compared to the 9.
I have a question. What's the rule for it to be a pyramid? Is it just that the side has to meet?
Ah, so that's what I was just about to get to. To be a pyramid, prism, base on bottom, base on top, it's cloned, connected by rectangles. Pyramid, base on bottom, point on top, connected by triangles. So that's the difference between prism and pyramid. Base, in prism, base is cloned, connected rectangles. In pyramid, single base, triangular faces going up to a single point. So, our formulas that we use. We are going to now start using the slant height, which you might want to notate a little bit bigger than what they have on here. For slant height, we use cursive L. That's what we use for slant height. And we only use this when calculating surface area. We only need that when we calculate surface area. If you're calculating volume, you will not need the slant height. So we only use slant height when we're calculating surface area. Now this, right here in the morning class, begged me not to cut this. Not quite certain why they did not want me to cut this. But if I take my pyramid out of, its shape and I look at the net, I've got my square base. Whatever it's called, this is a square pyramid, so I've got a square base. These triangular faces, I wish they were broken up differently. The one up top, you can see they were folded out like each direction. If I cut this apart, and I took one triangle and pointed it up, and the next triangle pointed it down. You've maybe done this with pizza, trying to make it fit back in the box, and the next triangle points up, and the next triangle points down. And I do that till I've run out of triangles. I will end up with a parallelogram. So on this parallelogram, and this might be sloppy because my orientation...
ladies do that with their pizza.
Yeah, to fit it on the pan. This is actually 4 triangles. So please draw, yours will probably be better than mine because my smartboard. Please draw that we actually have 4 triangles there. That's how the base edge is actually half the perimeter. So we can do our perimeter divided by 2, or half times the perimeter. And our height is just that slant height. So our formula looks very similar, but you gotta be really careful. This lateral area is going to be calculated differently than before. Because instead of having rectangular faces, I have what kind of faces? Triangular, which means they'll be half as much. So, when we come down here to this square pyramid, let's start with what's easy. Finding the base area is pretty straightforward, especially when my base is a square. Highlight or underline square. That tells me that big B is a square. So to find big B, I'm going to do this off to the side because it's real easy. How do I find the area of a square? Ready? You're not Brady. But it's easier than that, actually. You're right, length times height or length times width or whatever. But in a square, what do I know about my edge lengths? Like the name says, and like Carolyn just said, I can just take the edge length and square it. Yeah, sorry, it's my smartboard. There's a spot over here that keeps screwing it up. So that is B equals E squared. Yes, again, thank you, smartboard. I'm going to move over here, see if it likes me better over here. So my edge length of my base, what is it, Acacia? Edge length of... Oh, what's your question?
So what's the little b stand for again?
If we're using a triangle, it's the base of the triangle. Big B's area of whatever base shape I have in my whatever. So prism, pyramid, whatever my 3D shape is, big B is the area of that base. So here my base would be a hexagon. Here my base is a square, right? Because it's whatever the shape starts with. So this, my edge length for my base is 12. 12 squared is 144 feet squared. I'm going to circle this. It's a working number. I will need that later. Jaheim, you with me? Yeah. So, how do I figure out my lateral area then? What do I got to figure out first? This is where you got to be real careful. You now have multiple formulas that start with the same letters. We just did lateral area. We did perimeter times height. Yay. But now we're doing lateral area. Same letters, but it's not the same process. Caleb?
Is it?
You can look up your paper. Your formulas are there.
The 1/2 of the perimeter.
Half
Wait.
the perimeter
I don't know what that's
times the slant height.
Oh,
So we get half the perimeter times the slant height. Slant height, we use cursive L for length. It is the length from the bottom edge of your pyramid to the tip of your pyramid. That is why we use cursive L for length, and just not to use another H because it gets confusing. Now, another way we can do this, like we did last week, if you know that all of your faces are identical, solve for one of your faces and then multiply. That would work anytime you have a regular type of pyramid. Regular hexagon, regular octagon, whatever. If it's got regular in front, you can solve for one face and multiply. So, gravity works.
I said it first.
I need a bigger space. I'm running out. Okay.
Gravity works.
Yeah, right? Or I could have less things. So now, my perimeter, well, it's a square. What do I know about a square and the edges around it?
It's the same size.
They're all the same, so 12 times 4.
48.
48, so I have half of 48 times my slant height, right here, 10. Half of 480 is 240.
Good afternoon, Phoenix. Please pardon the interruption.
Sports.
We have information on our bulletin board about an upcoming all-Worthington Middle School dance sponsored by the Thomas Worthington High School football boosters. The dance will be on March 24th. Information is on the bulletin board. The tickets should be available for sale during lunch next Tuesday, Wednesday, and Thursday for $10. Tickets can also be ordered online through the Thomas Worthington High School football team's website for $11 or $15 at the door. Thank you.
Okay, I thought she would make a sports reminder announcement of who's canceled and who's not.
Wait, is it like a canteen or is it?
She'll probably do it right.
I don't know, you guys started talking and you weren't listening to the details, so go look at the info on the bulletin board. Like she started the announcement, there's info on the bulletin board. That's the first I've ever heard of it. So it's just annoying that you guys started talking and then immediately ask a question.
We were talking about what it was, ignoring what it was actually saying.
Yeah. So how much sense does that make? Not very much.
No, that was a really redundant conversation.
Yeah.
I agree. So, when you look at what makes up a pyramid, you got a bottom, which we technically call a base, because even if it was tipped like this and it wasn't the bottom, that square is still the base. And then, stop, dude. Why are you still making noises? Can you write down without making noises? These triangles are called my lateral area. How many bases do I have? One. I don't have to double this now. All I got to do is add these up. So add those. That will equal your surface area. That comes out to be 384 feet squared. You have, well, we're not going to do this right now, but I would encourage you, if you want to see, do I understand what I'm doing or not, to take a minute, chill here, and try this out. I will tell you the answer that you're going for, so you know if you get it right or not. If you choose to solve this one, your big B is, well, the area of the base square, that is 10 by 10. So your big B here would be 100. Your lateral area would be 40 times 11 times a half is 220. If you do this right, you'll get a total of 320. And we will go over that problem tomorrow. But if you want to try it, on your own, give it a shot. Thank you guys very much.